next we have Tim Terrill with Smart Load Testing for lazy engineers.
Hi everyone. Wait for the lightning thing to end. Cool. Hi everyone. So my name's Tim Terrill. I'm a staff performance engineer for ACV Auctions. Talking today about smart load testing for us lazy engineers. All right, so load testing is really important, right? It helps us answer questions like how much load can my service handle before it crashes? Right? Can our service handle a specific number of requests per second? And can our service respond in less than some number of seconds or milliseconds or whatever? So super quick survey. Who owns a system or service, or your company owns a system or service? Go ahead, raise your hand, like keep it up for a second. It should be many of you. Okay, with your hand still up, who knows the system breakpoints, like how much the system can actually handle before it crashes? Good, all right, some of you. And who currently has working performance tests in any language or framework? It doesn't really matter, so I see a few. Okay, great. So load testing is awesome, and to help figure out, how a system performs, you need what I call a performance baseline. Okay, so this graph here is intended to describe a specific service or endpoint and how it performs, its response time and its throughput. So on the left axis, response time, right axis, throughput, and typically, and then the x-axis on the bottom is virtual users, which in this case is just load, how many people are accessing this particular endpoint. So 10, 20, 30, 40, and so on. And you can see it's pretty characteristic. It's a nice straight relationship going up. And then at some point, the throughput drops off. And it's very classic. That's like what you see in most places. And when the throughput drops off, response time typically goes up as well. The question is, how much effort does it take to build one of these things? And I can tell you a lot, actually, especially if it's manual. All right, so our company does hackathons regularly, and our last hackathon project we called Dynamo. And what this page here showing is that to build a baseline test like that, it's a very manual process. The blue is manual thinking, like looking at data and analysis and trying to figure out, okay, well, did the system break yet? No, okay, it didn't, so I can add more load to it and so on. So going to do this and do this and do this. Maybe the test crashes and then you got to reload it and do it again. At some point, though, you determine that, okay, you found, where the system crashes. So, here's an example of one particular system at our company, and I had run 183 tests using Jenkins. Of note is the duration column there. So these tests themselves didn't actually run super duper long, but remember, before and after each one of these tests, you got to think, you got to do something before you decide if you're going to run another test. Okay, and that's one of the things is we use K6 to load test. It's a great tool, but it gives you lots of data. All right, many people, super smart engineers in my company, they're like, dude, can we make this simpler? Like, there's a lot to look at here. So there's 4 different endpoints. There's all different metrics all over the place. And how do you know, did you reach a threshold or did something go wrong? And I can figure it out, but it takes time, okay? So with Dynamo, this project that we did, it was literally a single command, run the command, and Dynamo would run a series of tests, okay? It would analyze the results after every single test, and it would stop when it reached the threshold or crossed the threshold, generate a summary for you, and then you could use it and move on with your day. And during that whole testing process, you could literally go be productive and do something else, okay? So here's an example with a fake service I made up. So there are 4 endpoints, and you don't need to look at the actual data itself here, all right? But Dynamo was running the test, looking at the results and saying, hey, we didn't cross our thresholds. So let's run it again. And there's an algorithm we built into this that said, hey, let's start at some start number, say 50 virtual users, increment by 10s for a bit, and then realize, you know what, we didn't cross any thresholds, let's go a little bit faster, so let's increment by 50, okay? And that's what happened, is we got to 100, and then the next test was 150, and then the next test was 200, and at 200, I circled it in red, we crossed our threshold. So there's this P98 column and this P98 goal, and, it said, oh, hey, 302 milliseconds is greater than 250 milliseconds, so, we're done. This is an end of test summary now, so we simplified all those metrics that you saw from K6, and our tools now spit out a result like this after every test, which is really great, easy to look at. And then at the bottom, it'll tell Dynamo does this expert analysis, and it says, oh, hey, this particular test was stopped because the Dynamo 1 fast P98 was greater than the goal of 250, and so was the Dynamo 1 no delay. So you could right away, very quickly, after waking up from your nap, you could find out that the service died, where it died, and why it died, and then you could go investigate further. So what's really cool is using, I forget what it's called, the matplotlib in Python. The code does this as well, generates this graph that I showed you earlier. This is the matplotlib version. And you can see on the left, the vertical white lines are real close together because that's when the Dynamo engine was like slowly incrementing by tens. And this is a different actual test than the slides I was just showing you, but it's a good example. And then after tens, it increased by fives, and then after fives, it went by tens, and then by 50s, and then it found the breakpoint. So this is super valuable at the end of every test at ACV where we deploy performance tests. We have the ability to run a Dynamo test and generate graphs like this. We don't do performance baseline tests in our pipelines. That's usually done elsewhere. Off to the side, these are the technologies we used. Thank you very much for your time. Have a great day.